Welcome back. In this lesson, we're going to look at the shoreline. We're going to look at what the ocean does to the shore, how it erodes the shore, in what ways, what features are as a result of this erosion, and then what we can do to try to keep it as long as we can. We're going to talk about the shoreline. You're going to need to talk about the shore. So the shore is that area of land that is in between the highest water that a storm would produce and the lowest water in a low tide. So all of that then is called the beach, and it's got deposits on it, sand, shells, other sediments that have been pulled up, dredged up from the ocean onto the shore. And so it is the shoreline that's affected by especially waves, also currents, and then the tides. And so those are these are all moving water events that are then going to shape the shoreline, change the shoreline. So a beach is the area where the sediment is deposited. Now, a lot of the beaches that you would swim on have been supplemented by sand. Sand is being dredged from somewhere else and then put onto that beach so that it's a nice broad place for people to come and enjoy the day. But the beach normally is just any of that deposited area, and sometimes it's lovely sand beaches, and other times it's just craggy rocks. It really depends on what the deposits are. Now, when you think of how the waves treat the shoreline, the waves are coming in sometimes straight onto the beach, where you have a nice parallel waves to the beachfront. Other times they're coming in at angles, and whatever features you would have there at the beach is then going to cause the water to move in strange ways. So water is waves, and so they behave like waves. In fact, you're going to see a lot the way the water works, the same way that, say, light would work or sound would work. They follow wave action. So one of the cool things is that it will refract, meaning it bends around corners. So when water goes through a narrow constricture, it's going to round back towards the headlands, which are these jutty out places. And then that can deposit sand, for instance, on one side and not the other. All kinds of things can happen as a result. The places that really get the most power from the waves are the headlands, and the headlands are the sticky out places. Any promontory places are going to be bombarded by waves, and then the bays, which are these inland parts, are not going to be so dramatically hit. So the waves, the breakers that are coming up and that you would see at the beach are going to be much more ferocious as they hit the headland. For that reason, these are very likely to undergo erosion. And so when they have erosion, so if you were to have a headland, so the dotted lines in this picture showing where a headland used to be, and as you had erosion, it's going to essentially carve off a cut, and this is called a wave cut. And normally it's just right under the water surface and it's flat, and it used to be part of that jetty out headland. You can get all kinds of cool sea stacks and arches and all kinds of things too as the water is carving into either hard or soft rock. So the sea stack here obviously belonged to the promontory that's sticking out. You can also see that you've got some arches formed as the water on both sides are continuously carving into that rock, and you can get sea caves, which don't go all the way through, but sea caves are where the sea is blasting in and carving into a cliff. Now, another interesting carver is going to be longshore currents. Longshore currents form when the water isn't exactly parallel to the shore, and when that happens, you're going to get some bouncing. Now, one of the things that's important before you understand the current is that there can be some sandbars along the beach. As the surf zone, which is shallow water, so you can almost tell where surf starts at the beach, because where you don't see waves and then where you start to see waves, what's happening is that it's getting very shallow in where it was deep water and then shallow water. All that energy is sending up sediment, and then as it loses that energy, it dumps the sediment. So you can have these strips of high sand there right at the beginning of shallow. Now, since you have some of these bars and the waves are coming in at angles, you end up with kind of a back and forth energy-wise, where the waves are punching into the side at an angle and then reflected off of that cliff or off of the shore or off of the beach. The resultant is that you end up with a current in the direction parallel to the shoreline, but in the same direction as the waves. So if the waves are coming in from the left to the right, the longshore current that develops is caused by the reflection of these angled waves coming back and ending up moving with the shoreline. Now, all kinds of deposits can be formed because this is pulling up sand and it's carrying sand. These currents are carrying tons of sand, and there's lots of energy there. So depending upon what is the lay of the land, you can have all kinds of different features. So this first one is where the shoreline has actually kind of sucked out back to sea, and you get what's called a rip current, where there's a break in the longshore bar, and once that it's broken, then the longshore current is essentially diffused and gets sucked back out to sea. This is a terror for swimming beaches. If you were to ever have a longshore current, which is normal, be able to go back out to sea, swimmers could be sucked out to sea, and it does happen. So there are a lot of different features, and a lot of these features, you're only really familiar with these features if you live by the ocean, because these are only found at a shoreline. So let's look at a few of these. The first one you see is if you were to have a sandbar that kind of connects the mainland to an island, that's called a tumbolo. And also you can have these bars that kind of go off to the side as you have the longshore current in this picture is going off to the right. That means that the breakers are coming in from the left to the right at an angle. And as it dumps its sand sediment, you can get these kind of sticky out places called spits. And if a spit completely covers a bay, you get a lagoon. So a bay is turned into a lagoon, and that's called a baymouth or baymouth bar. So you have a complete sandbar sealing off a bay, you end up with a lagoon. And sometimes that these if allowed to grow substantially, can actually be turned into islands. And so some of the barrier islands at one time were just sand carried by the longshore currents that are dumped and dumped and dumped, and eventually you have grass grow on it and trees and beachfront property. So there's all kinds of things that can carve the coast, but man can carve the coast as well. So what we do at the coast can affect things like erosion and pollution and wildlife loss and stuff as we are growing up, because so many people want to live at the beach. The beach is not the biggest part of the United States, but it's in terms of where people live. More people live near the coast than live inland of the coast. So some of the things that people will put to try to protect the structures would be seawalls. And seawalls can protect structures and save a lot of money, but they can also do damage as they reflect the waves back that can then erode beaches further. Another thing that people will do at a beach is they put in groins or jetties So a groin is basically a perpendicular, sticky out place, usually timbers or steel or concrete, that goes out into the water so that the sideways currents that's carrying lots of sand won't carry your beach sand to the next beach over. Okay, you don't want to supply your competitor with the sand that used to belong on your beach, so they'll stick that out to kind of catch the sand. Well, it's great on the side that's getting sand deposited, but it can also be bad on the side where there isn't sand deposited, and you can actually have erosion of any of the sand that's there. Another one would be jetties, which protects harbors. So these are sticky out places that that act as groins that on both sides of a harbor, so that it protects the harbor from waves, so that boats going into the harbor are not being knocked sideways as they're going. Breakwaters are often put in large ports because if you have rough water and you have boats that are moored, those boats are continuously going up and down and sloshed around. So if you can catch essentially the energy of the waves, then the water on the other side of the breakwater can be very calm, and you end up, so lots of naval yards and things like that would have a breakwater. You can end up with lots of deposits of sand on one side. There's always a payoff. In this chapter, the authors would like to talk about sea level, and that's of course because if you have climate change that many people espouse, that there is increasing global climates, then frozen water that's normally at the poles are going to be melting, and then that melting water has to go somewhere, and it'll go into the oceans, and then those ocean levels will invariably rise. So you end up with changes to coastlines because now you've got more water in the pool than you used to. You can, if sea levels were to rise substantially, low-level large cities would be devastated. Second is resources, and so you can raise an entire continent as it is being traveling or floating on top of this molten material underneath the crust. And so if an area of a coastline is actually raised up, then the sea level drops. If it sinks, then the sea level rises. So you can actually have changes that way. In the case of California, California is being lifted up. So parts that were underwater, okay, is now being lifted, and so you actually get what's called an emergent coast, where you didn't have, it was underwater before and now it's a beach. So essentially it's a new beach. So, and you can kind of tell where the old beach used to be and where the new beach is. Of course, in California you have lots of fault lines with upheaval as the oceanic plate is being forced underneath the coast of the western coast of the United States.